Okay, so the problem's on slide 14. So we have, first we'll do the one on the left first. Work done to lift a 120 kilogram concrete ball onto a 2-meter high box. So I've got that over here on my projector. Okay, 120 kilogram concrete stone needs to go up 2 meters. What's my equation for work done? Work done equals the force that needs to be applied to lift it times by the distance in which it's lifted. So this is easy, this is 2, right? We lifted 2 meters, okay? The force is where we have to think about this a little bit. So what is the minimum force required to lift this stone? It's the opposite of the weight, right? If I can balance out the weight, then in theory I can lift it. Now in theory you would need to go a little bit over, but we're just going to say if we make it the same, that would start to lift it. In theory, if you'd have to go, even if it was 0.00001 newtons over 120 kilograms, or the weight of 120 kilograms, then it would start to lift. So we're just going to say that if we can balance it, then we'll start to lift it. So basically we need to know what the weight is. Well, weight equals mass times gravity. Well, on the PowerPoint, they haven't used 9.8 for gravity. They've used 10. Right, so that's, some of you are asking me where the 1200 comes from. That's where it comes from. We've got 10 times the mass, which is 120. That equals 1200. Okay, so force is 1200 times by 2. That equals 2400 joules. That's the amount of energy or work required to lift the stone 2 meters. Okay, let's have a look at the other one. So the other one we have work done to drag a sled or sledge. I don't know what you call it here, I think probably sled. 8 kilometers. So the distance we're going is 8 kilometers with a force of 200 newtons. It doesn't give us a mass because we're not lifting it. So the mass or the weight and the normal force has no impact here, right? It's just how much what force do we require to pull it, and that's 200 newtons, and then how far are we pulling it? So this one should be a little bit more straightforward. 8 kilometers is 8,000 meters, right? Make sure we're in our standard units. So 200, or work done, equals force times distance, 200 times 8,000, and I'll take you back over here. That's 1,600,000 joules. Okay, you could put this in kilojoules. So this would be the first one would be 2.4 kilojoules, and the second one would be what? 1,600 kilojoules. No, 160,000 kilojoules. No, I had it right the first time. 1,600 kilojoules.